Hello, this is AnthonyL with Team Sadis, and this is going to be my Individual Progress Report 2 over our 2D Java game named Soul. So to start off, we're going to go over the status screen user stories. As a status display screen, I want to appear on the center of the game window so that my information is clearly visible to the gamer. The next one, as a status display screen, I want to show the gamer the current level so that the gamer can view his game progress. As a status display screen, I want to show the gamer the current primary and secondary weapons so that the gamer can view which power-ups he has. As a status display screen, I want to show the gamer the current health so that the gamer knows how close they are to losing. Now, the best way I thought it was to approach this problem I had, I put the status display screen on a key listener for the actor class. Our hero is the only class that extended actor, and it was the only class that was going to use the status display screen, so I just went ahead and put it on the actor. Whenever the C key is pressed, the status display screen is displayed. And this worked out perfectly fine because it was a simple operation. We just needed a key listener. When the key was pressed, it fired the status display screen, and there it went, showed all the relevant information and fulfilled all of the user stories for that epic. Now for the next major thing, I had a victory screen, which was really similar to the status display screen. It was just displayed at a different time. So I had to approach this problem a little differently. So let's go ahead and go to the user stories. As a victory screen, I want to be displayed when the gamer defeats a boss on each level. As a victory screen, I want to contain a button the user can click to exit the current level and go back to the world map. So this UML is very similar, it's just a little different. I had to tie the victory screen to the abstract boss class, which turned out to be much better than tying it to each individual boss class themselves. So this way I only had to tie it for one key listener on the abstract class because all of the bosses derived from that abstract boss class. And that worked out perfectly fine. And again, another simple solution, we just needed to utilize a key listener on a superclass. Okay, now for the next couple of stories, they're very similar. They're all different kinds of weapons that I had to design for our game. There's a lot of crossover between them, but each one is also very different in its own right. So I'll go ahead and go over the user stories for the grenade weapon first. As a grenade, I want to be fired by the player when the player clicks the right mouse button so that I can travel to enemies. As a grenade, I want to travel in an arc so that I can hit enemies from different angles. As a grenade, I want to collide with objects so that I am able to explode. As a grenade, I want to damage enemies when I collide with them so that I can destroy them. Now let's go over the Seeker missile user stories. I'll go over all of the UML after I finish the weapons. As a Seeker missile, I want to be fired by the player when the player clicks the right mouse button so that I can travel to enemies. As a Seeker missile, I want to travel to right mouse click locations so that I can hit enemies from different angles. As a Seeker missile, I want to collide with objects so that I am able to explode. As a Seeker missile, I want to damage enemies when I collide with them so that I can destroy them. Now we have the last weapon, Flat Cannon. As a Flat Cannon, I want to be fired by the player when the player clicks the right mouse button so that I can travel to enemies. As a Flat Cannon, I want to travel in a short burst radiating outward from the hero so that I can hit enemies right in front of the hero. As a Flat Cannon, I want to collide with objects so that I am able to explode. So now let's jump into the UML. The way that we designed the game, and this is a very important part, we had an animator controller, which the renderable object as a superclass used. Now everything that we rendered on the screen pretty much was a child class of renderable object. So for here we have the actor and then we have the hero, and over here on the other side I made an abstract weapon class which all of the other weapons derive from. The superclass abstract weapon class contained most of the collision detection logic in there and the controllers as well for the animation and the physics controller that we used. And for this, to solve this problem, I also just used a key listener. There's a key listener attached to the actor, which the hero class derived from, and whenever the right mouse button was clicked, one of the secondary weapons would have been rendered on the screen, and the logic for updating, rendering, all of that would have followed. The way we tracked this was we had a integer value in the hero class. 0 was for grenade, 1 was for seeker, flat cannon was 2. Um, and depending on what the value was in the hero class, when the key was clicked, it would render one of the different weapons. And inside of the weapon class contained all the logic. Would it just go in an arc and explode like the grenade, which we just had a couple of forces. So depending on which direction the hero was facing, we would add a left or a right force, and then we'd add an up force. And we'd let the rest take care of it because of the physics engine that we had. For the seeker missile, wherever the mouse was clicked, we'd take that location and we would use that location and the hero's current location and get a delta for the X and the Y, and I would add that much force for the X and the Y components respectively. So that one was pretty simple as well. For the flat cannon, depending on which way the hero is facing, we would just add a left or a right force. It'd be the same every time because it just always went the same short distance. And that is it for me. Thank you very much.